Hello, and welcome to the webinar. Today's webinar is entitled Prepare Your Machine Learning Data 4 Times Faster. Now, before we get started, I want to do just a little bit of housekeeping here. When you joined the webinar today, you selected to join either by phone call or by computer audio, and we want to let you know that you have the option to change that should you have any technical difficulties during the broadcast. Simply go to the control panel there and change or choose a different method of audio. Now, also from that control panel, you have the opportunity to submit questions. So if you see the questions pane down there, I want you to use that today. We're going to use that to get the questions to myself as well as to Paxata, and we're going to get those answered for you live on the air today. And if we don't get to those questions, this broadcast will be recorded with a follow-up email, and we will try to get all questions addressed as best you can, or as best we can. So my name is Christopher Burns. I'm an artificial intelligence and a machine learning solutions architect here at AWS, and I'm going to be your host and moderator for today's webinar. Also with me today, I have Pete Laubser, Senior Vice President, and Global Head of Marketing at Paxata, as well as Martha Miller, Senior Solutions Engineer at Paxata, and they have some great information to give you today. But before we get to the partner, we're going to go. I want to just briefly touch on today's agenda, as well as what our learning objectives. So the agenda is we're going to give you an overview of machine learning on AWS, as well as how it affects our AWS partner network, and we're going to hear from Paxata themselves right after that. And then finally, we're going to do a Q&A session at the end there. So like I said, if you have questions, get them into that box. We'll get them answered for you live on the air today. It's a great benefit to ask your questions here today and get this live answer rather than via email. Now, what we want you to take away from this webinar today is we want you to take away some information on reducing your data prep for projects from 80 to 20%. That's a huge number. So that's a gigantic number. If you have any machine learning practitioners out there in the audience, you should appreciate the time it takes to prepare and collect these data sets for machine learning. And hopefully that sounds appealing to you. And the ultimate goal of that reduction in preparation time is to accelerate your data science and lake projects. Because really, when we talk about this, it's all about delivering results, right? We want to get these out of R&D into production and into the business processes. And then finally, we want to show you how to leverage built-in machine learning algorithms to clean, excuse me, to clean and shape data for your data science initiatives. So very briefly, as I mentioned, I want to touch on machine learning on AWS. I'm going to talk about machine learning as soon as I get the slides to work. A little bit of irony there. Okay, great. So at Amazon, we've been making investments in machine learning for over 20 years. Sometimes it's behind the scenes, sometimes it's not really apparent, but I want to talk about Amazon for a moment holistically. Sometimes we separate Amazon.com from Amazon Web Services, but we are all one family. We share research, we share creations. And so I want to make sure that you understand that we're talking about Amazon.com as well as AWS services here for the next couple of moments. And it's important to remember that many of the capabilities that Amazon.com uses, that our customers experience, were all driven by machine learning created internally and then offered to our customers. AWS itself was originally an internal creation at Amazon.com and then exposed to be consumed by external customers. And so within that vein, I'm going to break this machine learning family down into just a couple of sections. So first off, let's talk about our fulfillment centers. If you've never had a chance to visit one, I highly recommend it. To watch the robotic optimization in the path planning, to see robots whiz by each other to stop if a human is present and then resume. It's really impressive, and not just from an entertainment perspective, but from the orchestration of math and machine learning that's happening behind the scenes there. Let's talk about for our moment our recommendation engines. Amazon. I'm sorry. Is there a question? I apologize. I thought I heard somebody talking. So back to our recommendation engines. When you visit Amazon.com, you're presented with a wealth of information about products, related products that other people have bought, similar products, which is pretty handy when you're looking for the next book that you want to read. So that recommendation engine is working on a massive amount of data, and those have been maturing behind the scenes for many, many years. Prime Air sort of falls into that same family as our fulfillment center drones, except we've added computer vision much more to the mix there. And we're also working in a spatial area rather than just two-dimensional. So we have our voice-driven interactions. I'm going to dedicate a slide to that in just a moment. But because machine learning is a recombinant technology, meaning it can be combined with nearly any existing technology to create something new, we have many opportunities to infuse ML with existing products as well as creating entirely new products. If you've ever used Amazon Fire TV, there's a feature there called X-ray. And so if you hit pause, it's going to tell you the actors, actresses, and some great metadata that's in that scene. So that's all driven by AI. Amazon.com owns the IMDb database, and that gives us access to those celebrities. And also we'll see a celebrity recognition feature in a few more slides. So our mission here at Amazon AWS is to put machine learning in the hands of every developer and every data scientist. I like to add builder into that phrase, put machine learning in the hands of every developer, every builder, and every data scientist, because we can't all be developers, we can't all be data scientists, and sometimes you just got to build something. So that's a pretty lofty mission when you think about it, because data science is difficult. It's difficult for data scientists to understand and gain the knowledge that developers and the DevOps have, and it's equally as difficult for developers to just jump in and assume the role of a data scientist. So back to that slide I told you about our voice products. If you don't recognize this, this is the Amazon Echo. This the first version of the Alexa persona. I'm sure hopefully you've heard about that. Now, Echo has turned into an entire line of products, all voice-based. It was probably the first consumer product to bring voice recognition really into the mainstream, into the home. And with it, it brought automatic speech recognition, continuous speech recognition. And if you've been paying attention, you'll notice that the new line of Echo products are starting to appear with cameras, with screens. And I'm not going to speculate on future features. Please don't think this is speculation, but you can begin to see some of the new capabilities that's going to bring when you add computer vision to NLP in the home. So speaking of computer vision, and just a little disclaimer, this is where my personal research and my personal favorite area of studying AI is computer vision. I want to talk briefly about the Amazon Recognition Service. We're going to see it again in another couple slides when we see the entire AWS ML stack, but I want to draw attention to it here to just show the rich array of features available in this service. So we have object and activity detection. We're going to come back to that also in a moment, but I want you to take special note here of the phrases there, object and activity detection. Now, if you've been paying attention to the computer vision field for some time, you notice that this used to say object classification. So we're going to come back to that here in another slide. Person pathing, a very clever way to say, that's tracking of individuals. There are countless use cases to put that into play. If you've ever taken your kids to an amusement park, you can immediately see the value in person pathing. That's available to you via the recognition service. Facial recognition, as well as, so we sort of downplayed it. That service within recognition actually comes with a wealth of features for demographics, sentiment analysis, age, guessing. So there's a lot of data there along with that facial recognition. Now, real-time streaming. This is, I want to make sure I draw the distinction here that this is available, this service, with still images, as well as video feeds. So you can process either one. Content moderation is a great one for any service that's going to be publishing pictures from users, from social sites down to any other type of who knows, a school function. It can detect and filter out mature content before it's published. And then finally, last but not least, we have celebrity recognition, because sometimes you just need to recognize celebrities. Okay, so I had talked about object classification versus object detection. I'm gonna address this picture in this slide in just one moment. But first, what I want to do is I want to talk about object classification. And what that means is, given X number of classes, we call them classes in machine learning, or objects, can we detect them in an image? So in this particular image, if I were to say, are there humans in this image, it would return a result of yes with a confidence score. Now, what object detection is it detects where an object is within an image. And that's usually represented by what's called a bounding box. Now, I don't have an example of a bounding box here, But obviously you see where these labels are. There would be, if you just imagine a box around that object. And now what that does, what the object detection does, is it allows us access to things like proximity, to relationship. And what we can do with this, we can build on object detection and move to scene detection. So if I could draw your attention to the slide now, we see here we have on the far left a balloon, a gift, a child, and at the very top of the screen in the middle it says party. So you cannot train, well, I shouldn't say you cannot. It'd be incredibly difficult to train an algorithm to detect a party, but you can train an algorithm to say, if I see all these elements, I can make the assumption, I can make the inference that there is a party. And then down at the bottom, we see opening present. That's event detection. That's incredibly powerful. I know I sound probably like a little bit like a kid at Christmas about this, but it's incredibly powerful technology. The evolution's happening right here in front of us. And oh, by the way, Recognition has a great free tier. So if you want to try this out, you want to set up some images, set up some videos, you can do that pretty much at no cost. I'll be mindful of my time here. I do apologize. I'm going to go quickly to the AWS machine learning stack. So we call the stack is a holistic view of all the services available to you from AWS when it comes to machine learning. At the top layer are our application services. So we have Recognition, image, and video there. We just talked about them in depth. Our speech services, we have Polly, we have Transcribe, and with our language services, we have Translate, Comprehend, and Lex. So these are features and services ready to use. They're available via a very clean JSON API, no coding required. You simply send a payload with an image or with some text, and you get the response back. That means you can infuse this directly into your projects without any research, without any training, and really hit the ground running. Platform services, a bit of a middle tier, if you will. These are services that are for teams. Amazon SageMaker was built to connect data scientists with the DevOps. You're going to train and you're going to provision endpoints. You're going to host endpoints without ever worrying about provisioning resources on your own. It's a completely managed service. Deep Lens is going to give you inference at the edge. You can push your models to the edge on this camera, and you get inference right there at the edge, which opens up a whole world of possibilities for taking action at the edge as well when you have a scenario where you need very timely inferences. We have Spark and EMR. So if you have, obviously Spark ML is an incredibly popular library, and EMR, so we handle all your big data needs as well as individual research and development on frameworks. And then we have Mechanical Turk. Real quickly, it's playing a bigger and bigger role. Mechanical Turk's actually been at Amazon since the beginning. But the reason it's significant now is if you have 1 million images that you need to label before you can run them through, through a machine learning training process, it's very difficult, very time-consuming process. So you can turn to a crowdsourcing mechanism like Mechanical Turk and get that done. And then finally, we have frameworks and infrastructure. We welcome all ML frameworks at Amazon, whether it's TensorFlow or MXNet, CNTK, Caffe, PyTorch. They all run as equally well. So you can bring those to our infrastructure and it will run just fine. And then finally, we have a wide range of, a wide array of selections for training. Sometimes you want to train on CPU. Maybe you're doing some XGBoost or a linear learner type algorithm. And sometimes you want to train on GPU. So you've got some neural network activity there. A fleet of P3s will crunch through data with a quickness that will impress almost anybody. We also have the FPGAs. So once you settle on an algorithm, if you need that algorithm to run in a highly optimized manner, you can look to these field programmable gate arrays. Don't like to name drop, but we are proud of the customers that are running machine learning workloads on AWS today. And then finally, I'm going to take a couple seconds here to talk about the machine learning competency. Our partners at AWS, nearly anybody can be a partner. You sign up, and there are different tiers to partnership with different benefits. But to achieve a competency, you have to go through a very rigorous process by which you present use cases in a particular area. In this case, we're talking about machine learning. Now, I personally vet these use cases myself. I'm personally involved in this program, so I know the bar is incredibly high to get this competency. So while we kind of represent it here with this little gold badge, the truth of the matter is the partners that have this competency are really good at what they do. They come as certified, trusted partners to handle the most complex machine learning processes. And speaking of partners that are very competent, I want to now introduce you to Pete. Pete, as I said, is the Senior Vice President and Global Head of Marketing at Paxata, and he's going to take it from here, and he's going to give you some great information on Paxata's services. Pete?
Hi, Chris. Thank you very much for the introduction. We're super proud of being one of your competency partners for AWS Machine Learning. So let me just see if I can get controls of the slides here, and it looks like I'm off to the races. There we go. So let me quickly kick off with just a quick snapshot of who Paxata is. We have been founded in 2012, so we've been around for 6-7 years already. We've got offices in a number of locations here in the US as well as internationally. And Paxata is focused on providing an enterprise-grade self-service data preparation platform that is aimed not just at programmer and sort of IT technical developer type people. The focus is on empowering the business consumer. Our architecture, and we'll spend a little bit of time, is built on a sort of a very powerful elastic scale out platform, so allowing us to scale with your data needs. We obviously have been certified to run within the AWS environment. We'll touch on a few customer use cases, but we've got customers across all kinds of industries, all over the world, deploying us in machine learning environments, data science, deploying us also in regular analytical type platforms. And lastly, we're pretty excited. Last week, Forrester released the latest wave for data preparation applications and solutions, and so we have been named as one of the leaders within that wave. So we're really excited about that. So let's jump into how Paxata can help. So I think most of us have seen this little statistic here in some form or the other. But most of our projects and the cool things that Chris had shown us start with data. It starts with getting access to data and then shaping that data into the format that is applicable for your purpose and for your project. Our traditional mode, and this has been going on for 20+ years, has been as let's go ask somebody in IT and developers and technical people, because they're the only people with the tools. They are the only people with the skills and the know-how. And so what ends up happening is this back and forth between the business who request the insights and the IT people who know the technology side of things. And there's a constant exchanging of, well, is this what you're looking for? No, I want it looking slightly differently. And in the end of the process, is this could consume 80% or more of time. Now, if you sort of look at, Chris alluded to this, is if you do 100 of these projects a year, it's like if every one of those projects have an 80% overhead, then eventually as we spend very little time on insight development. And the reason is simple, that data in itself is just a raw element. It's not the insight. It's kind of interesting when people say data powers or is the oil for or the fuel for digital transformation. Data in itself can do nothing because in its raw format, it's not contextualized, it's not consumable, it's not integrated, it's not clean. And it's not about just bad quality data, but it's when in one system, a state like California is spelled as CA, in another state it's called California, doing any kind of analytic on this become very complicated. And so really the process that we need to go through, and we need to do so at absolute scale, is how we take masses and masses of raw data sources, raw data elements, and compile that into something that is complete, that is clean, contextual, and consumable. And now we have that information that we can then use to be the inputs in our machine learning projects, into the analysis that we want to drive on the other side of our project. Now, there's been a couple of companies that we've worked with has actually changed this this dynamic in a very big way. HMS is an interesting organization in the healthcare space. They collect data from multiple providers and external organizations, and they're trying to detect fraudulent patterns in data submissions, in claim submissions and things like this. Now, you can imagine is when you work with two providers, you're going to get two different formats of data. So if we push this through a back-end process that is IT dependent, not understanding the context of all of the data elements that might be coming in, it can take very, very long. And in the case of HMS, some of these processes took them upwards of 300 days to compile the data set that they can be utilizing. And they managed to decrease that by some 70%. Oath is another interesting one, perhaps not as familiar, but this is when Verizon acquired Yahoo and AOL. And this is not a machine learning activity, but just to sort of bring home the value of empowering business with the capability to work with the data directly. A project that was suggested to take multi-month, 22 months, was the estimate for integrating multiple ERP systems into this newly created Oath entity was accelerated by 18 months. And the reason is that they can put data preparation, data access in the hands of business consumers who could then understand and clean and manipulate the data for use in the purposes. And then Standard Chartered Bank has achieved a 95% faster regulatory reporting within their environment, once again by empowering people closest to the data, the business consumer. So that's really at the heart of what Paxata is aiming to do in this market. Is we have good developers around our organizations. We've got data scientists in every organization we talk to. Those say is that we don't have enough. How do we get more people in on the act? And so what Paxata's set out to do when we started 6-7 years ago was to empower the everybody data analyst, the citizen data scientist, yes, the data engineer and the data integration developer, and the hardcore data scientist. We can help you and empower you, and by providing a very, very user-friendly, a Excel-like visual experience, we can bring more people to the project. We can bring more collaboration, more interaction. And what we achieve in the result of this thing is we speed up. We speed up the process. We speed up the accuracy of the data by multiple folds. And as we're going to go through the demo in a couple of minutes' time, Martha's going to show you exactly how some of these things work in that environment. So how does it apply to machine learning specifically? Well, like in everything else, as I said, step one is, where's my data, dude? Where can I find data? I've got data from multiple locations. I've got some data on data lakes. What's in it? Well, it's not documented. These things are not strong on metadata. So the first step is getting and understanding and profiling the data. Once we have 2, 3, 4 data sets that we want to combine and work with, we need to now clean. We need to prepare. We need to shape it. We need to manipulate it. And then do sort of exploratory analysis on top of that data to really begin to form some hypothesis. And then we input this and to train our models. We create test data sets and we improve and the cycle starts again. And so all of this iteration process, and specifically in step 1 and 2, is where Paxata can be of massive value and acceleration, even if you are really, really proficient at scripting and developing in Python and all these sort of more programmatic type languages, is doing it visually, doing it iteratively, doing it in collaboration with your business peers will accelerate your project in a big way. Let me jump to the next slide. And so here's a couple of these examples, and you can see on the left-hand side sort of a snapshot. But as I said, the step 1 is profile, identify key characteristics, data elements that we want, understand whether my data sets are skewed in any form and fashion. We want to be able to clean it, normalize it. I mentioned it earlier, as if you've got in one system, something is called CA for California, another one it's spelled California, spelled out, and another one it is maybe misspelled. Is like, how do I quickly standardize these values? Create rules. If there are missing values, how can I come up with an easy computable rule that can help me fill in the values there? Making the data consistent, formatted, and also allowing me to engineer new features in my data set by decomposing values or transforming data to represent data in a fashion that my machine learning algorithm can actually understand very well. And we're going to see all of these things in practice. One of our showcase accounts that we work with is a company in the pharmaceutical business, and so this is a great example of what most of us are struggling with. And what they wanted to do is is to basically leverage more than 30 years of clinical trial data coming from 100+ countries. And you can imagine is somebody is looking at this and say, there must be some gold in there. There must be something valuable in there if we can just get access to this data. And so all of the teams that are developing new drugs basically could not easily get access to it. And even if they can get access to it, it's very, very difficult to analyze. And what they've done is by implementing Paxata in the environment, they allowed the data scientists, the data analysts, the people closest to the need at that point in time to actually discover data by themselves across all of this vast repository of information that is out there. And they could build the data preparation tasks and routines and recipes themselves, make data available, and actually begin to reuse data from previous projects. And so by doing that, as they were able to accelerate their project delivery times, the outcome times by 8x, as you can see there. And all of this done in a code-free environment. So it's not to say that you don't want to code. There's a time and a place where coding is obviously right. But if everything is done at a code level, we just don't get acceleration. And it's very, very difficult to bring more people into the environment. So at a nutshell, if you sort of take a big step back and you say, so how does Paxata work? Well, kind of 3 phases to the thing. As there's data coming in from a number of places, we ingest this into the platform. There's intelligent mechanisms. Martha's going to show us how some of these work. You can, with one click, you can profile, understand your data, documents exactly what's in it, you begin to visually explore, and then you begin to clean and shape the data. There's intelligent algorithms and machine learning embedded in the platform that make recommendations so that you don't get something wrong, whether it is to standardize values or whether it is to join data sets together. And then ultimately, you can share this, publish this out again into the environments that you want to, whether it be into your AWS data lake, or maybe it's in the machine learning environment, or you want to use AWS SageMaker. So that's kind of at a high level, the flow that we're aiming to work. What makes us unique? 5 things that we tend to want to talk about. One is that visual interactivity, but at scale. Quite a lot of time when you see these kinds of data preparation environments, they work on small samples. Samples are cool because it seems very fast. The problem with the sample, it doesn't tell you what's wrong in your data set. It tells you what's wrong in the sample. So if you've got a big data set and you want to know all of the outliers, the skewing of the data sets, a sample is meaningless, right? So you want to be able to work at scale. We're unique in the sense that we're actually powered by running on Spark. And so we can run at pretty big scale. Intelligence, built-in algorithms give you recommendations, guide you, help you understand and accelerate the process for you. We talked about that sort of adaptive nature, the elastic scaling of the environment that is absolutely critical. A lot of these data projects come and go. So you do not want to have 24/7 paying for your cluster running. We are not going to use it like that. Or if you're only going to use this for 3 weeks, then pay for the 3 weeks. So we allow you to actually scale and adjust your cost and performance dynamics to help there. It's governed, it automatically is keeping track of everything you do. It actually, every step you make, think about you're working in an Excel environment, you create a VLOOKUP, or you modify the value, or you added a column. All of these things are documented. Now you can have data lineage and you can track what was going on. And the last bit is that collaborative aspect that we're talking about that is really, really critical. So being able to share data sets and work together. So with that, I am going to hand over and get Martha to take us through the demo.
Great, thank you so much, Pete. This is Martha Miller. Let me just share my screen and bring up the browser so we can get into the Paxata demo. If one of the panelists or someone that can speak could just confirm that you can view the Paxata UI, that would be great.
Yes, we can.
Perfect. Okay. So I'm logged into Paxata right now. The interface is via the browser, so there's no desktop downloads or desktop software. I'm logged into Paxata, and what we're looking at now is something that we call the library. This is where we catalog data sets that are available for data preparation. And I have a few data sets that are already listed here. Of course, I could import data on the fly from S3, from Redshift, from other data lakes, from on-prem relational databases. But in this case, we're going to start with a retail transaction data set. And my goal in working with this data is actually to to prepare data to feed a model which is going to help me predict and target my most profitable customers. So I'm starting with a transaction data set from the previous month, from October, and I just ran a profile on this data set, which, as Pete mentioned, is sort of step one in the data preparation process. And the profile shows me, for each column in my data set, a lot of information, sort of a scorecard about the completeness and the consistency of this data. This will give me some pointers as to where I need to start my data preparation work. So I can see, the number of rows. I have some blanks when it comes to loyalty programs. Not all of my customers are part of our loyalty membership, so that makes sense. I scroll across and I can see number of unique values to validate keys. A little bit more sophisticated things like phonetically unique values and possible phonetic duplicates. So this is leveraging those built-in algorithms, and I can see there are some pretty highly inconsistent data in both the city and state columns. So I'm probably going to want to look at that and start to clean that up. And then some other metrics about the min and max string length, nulls, etc. So step one is understanding how good is the data that I'm starting with, so that I know exactly what I need to do to prepare it for machine learning. So we do that data preparation in the context of a project. So I just toggled over to the projects pane, and I have in this environment a project that is already seeded with that 2 million row data set. So I can scroll through the data in an interactive online environment. Again, it's very intentionally really very much like Excel, where I can scroll across the rows and columns. And what I've presented here are 2 filtergrams on the data on those city and state columns. So I can see here in my state column that I do have some duplicates. And in fact, I might want to, it may just be a matter of cleaning up the case or making the case consistent. So I understand, maybe some data anomalies by looking at the profile. And then by clicking on any column, I'm presented with, and let me just expand that a bit, I'm presented with a menu of drop-down options. So this is where I can start to clean the data. Making the case consistent is perhaps step one. So I've just selected, I'd like to make the state, and in fact, I can select multiple columns. So perhaps the city and state, I want to clean up that data and make the case consistent to capital case. Paxata shows me a preview of the change that I'm about to make. And when I click save, that change is applied and the data is updated. And the number of unique values in my state column has actually decreased. So I'm starting to clean and normalize this data. And now I can filter and understand, well, do I still have potential anomalies? So I've selected New York, which filters the data down below, also filters the cities. And I can see that there are some duplicates here that weren't addressed by that case inconsistency. So this is where I might need to leverage one of the more sophisticated transformations to find similar values in this data. And for that, I'm going to select cluster and edit, which brings up a menu where I can select not only the algorithm that I'd like to use, but also the method by which I'd like to cluster similar values together. So in this case, Paxata, using a phonetic algorithm, so looking for phonetic similarities, found 11 clusters in this 2.3 million row data set. And if I want to cluster to the most frequent value, I simply check that box. If in some cases the most frequent value may be incorrect, I can select a different value or even type in my own default. So this is where, leveraging my knowledge of the data and how it should fit together, I can make those adjustments. I select save, and now I've normalized the cities as well. So we've got 80 unique city values and clean states. I feel pretty good that this data is clean. And now I want to turn my attention to making sure, well, do I have the right data to feed my model? If I want to look at predicting purchasing behavior in the winter, I'm focused specifically on October as a starting point. And when I bring up a filtergram on the transaction date, you can see it's presented as a calendar, and I can very quickly see that I have some outliers. As I make this selection, I can see that somehow there are few records, just 3 out of those 2.3 million, where the dates seem to have been transposed. So clearly that's a problem. I don't want to include those records in my model. So I'm going to highlight those. As well, it appears that perhaps there's some data that isn't in October. And when I make this selection, I can see I've got some September values as well. So I've highlighted these outliers. I actually want to take these out of my data set because they don't fit the criteria that I've established. And so I just clicked on the scissors, and by clicking save, I've just removed these rows from my view. Now I haven't changed the source data, I'm just changing the data that I'm working with interactively in Paxata. So now I have all the dates in October. That's great, that's what I'm looking for. I may want to break this out by other date parts, or more likely, perhaps I want to add additional features to this data set. For example, deconstructing the transaction date, perhaps adding a new column using some of the built-in functions, again, very similar point and click like Excel. What I'd like to do is actually, instead of just presenting the date as it is, I'd like to be able to look at day of week as well as, so I can understand, purchases on the weekends, purchases on weekdays. So I've added this new day of week column, and you can see that's now added to the end of my data set. Also want to look and be able to flag purchasing patterns and values. So my goal is to focus on the most profitable customers. It's important to know and highlight. I've just brought up a filtergram on the amount spent. There are a lot of returns in this data set. In fact, all of these values less than 0 were actually purchases that were brought back. And so that's something I'd like to flag. I'd like to create a new, really a binary flag on returns. And I can do that, again, through point and click. So I've selected everything less than 0. I'm going to go ahead and create a new column for return. And I'm just going to populate this with a 1. Anytime that condition is met where the transaction amount is less than 0, I just want to populate that return column with a 1. And so now I can see those are represented here. And if I wanted to fill in the remaining values so that, again, the machine learning model could pick up 1s and 0s, by selecting these transformation options, I can perform a pretty simple find and replace. So anytime there's a blank, I'd like to replace it with a 0. This is now creating a flag for my returns without even writing a formula, right? It's point and click. It's very easy for anyone that's comfortable in Excel to be able to perform this type of flagging and variable creation. And if I wanted to do something a bit more sophisticated, coming back to the computed columns, I'll just bring this up again. If I wanted to, for example, flag large transactions, I can determine what the criteria is for that. So if I wanted to say, well, if the total amount is greater than 100, then populate with a 1, else 0. So again, very similar to the same type of syntax I would use in Excel. I've just created another new column for large transactions. I click save, and I'm starting to really complete the types of data features, doing some feature engineering to augment this data set so that it's optimized to feed in to my machine learning models. In addition to these types of binary variables, if I have categorical data, so if I scroll back here, looking at card type, if this was an important variable to me, I wanted to understand payment terms. Perhaps I have a loyalty credit card or program that I wanted to understand. The way that this data is structured, each card type is actually listed with a label on the transaction itself. And what I'd really prefer is if for every line of transactions, again, I had a flag as to which card was used. It's a technique that's often referred to as one-hot encoding. And it's actually very simple to perform in Paxata through one of our shaping exercises. So I've selected an option from the toolbar over here to reshape or reorient the data. And that can take a few forms, deduplicating, creating new group bys. In this case, I actually want to perform a pivot on that card type column. I'd like to see a count of the card type added to the columns. And then in the rows, I'd like to continue to see some of those key points of information that we've been looking at. So I'll just go ahead and select really the key attributes about this transactional data, certainly the new columns that I've selected, keeping that date in there. And so I've just selected to sort of reorient this data set. And as I scroll across, I get a preview. I always see a preview, this interactive user experience, a preview of the change I'm about to apply. And when I click save, now I have these 4 new columns about the data set. So for each transaction, I can now see exactly which card type was used, again, with that type of that variable flagging. So this is great. In about 10 minutes, I've done a lot of work with this single data set. As Pete mentioned, it's often a requirement, I would say, very frequently a requirement to join data sets together. And so Paxata makes it very easy to work not only with a single incoming data set, but also to append additional data of the same form or even perform lookup operations. And I'll just walk through that very quickly, where I can select a data set from my library, or I could import data on the fly. In this case, I want to see, well, this transaction data that I'm working with, if I have a data set that represents additional demographic information about my loyalty customers, I'd really like to add that into this work so that when I publish the results, all of that customer demographic information can feed the model as well. And so what I've selected here is I'd like Paxata to calculate the join score. This means that Paxata is going to look across the data sets that I've selected and automatically look across the values, so not the column names and data types, but the actual values to find potential matches. And you can see that Paxata found a match, the highest match between first name and last name and full name in my loyalty program data set. This is a huge benefit to, particularly for non-technical users that may not know how data fits together, or if you have a new data set coming in that you're not familiar with. If you know how you want to join the data, certainly you can pick the columns, or you can let Paxata do that hard work for you. But even if you let Paxata do the hard work, you still have some control. So I just selected this options tab. This is where I could choose, do I only want to keep the matching rows? Do I want to bring in all the rows? Is it a lookup or is it a join? And then finally, have some control over the fuzziness of the match. So if I only want exact matches, Paxata wouldn't find first name, last name, full name. But I'm going to keep the defaults. In this case, I'll click Save. Paxata is creating a wider data set now. So you can see over here to the right with this new column header, I have my loyalty data populated here. It's joined up against my original data set, and then I have a sources column. So this is great from a lineage perspective because now it's very easy for me to highlight. If I only want all the rows that match up, I can simply make that selection. Or if I want all the rows, I can leave this filter criteria off. So I've now combined the data sets. Just one last step I want to take before I publish the results, and that is if there are certain columns that are still remaining in my project that aren't really pertinent to feeding a machine learning model, like transaction ID, not very helpful, I can just hide that. If for whatever reason I needed to move columns around, this columns editor allows me to, again, point and click and select exactly the columns that I'd like to publish in the order that I need them. And when I click Save, that change is applied. And the last step here is that I'd like to publish the data from Paxata. And I do that through a lens. And it just occurred to me, this is the first time we've seen this steps panel. So as Pete mentioned, the benefit of Paxata is the governance and the lineage and the audit trail that we provide automatically. So you can see all the steps that I've performed along the way. These steps are editable, so I can go back and make changes. But at this point, let me just finish this workflow by saying, well, this is my clean data for machine learning. I've created this publish point. I'll save that and then actually click publish. You'll notice I'm only publishing the data that matched. So I'm only publishing my loyalty data. I'm publishing this 1.2 million rows. And if I just come back to the library, I can see here is that data set that's been published. It just completed. There's the data. And now I can easily push it to S3 or any other supported data source. If I push to S3, I can, of course, choose the format of the file that I'd like to publish out to that S3 bucket. And I can do this on demand, this publish on demand anytime from the library. And Paxata supports automation as well. So if there's a workflow where you need to import data sets, apply the cleansing techniques, apply the feature engineering to create those new rules and new columns, and then publish the data out. You could run that on a scheduled basis as well as on demand. So with that, that was a whirlwind tour of Paxata and the ease in which really any type of user can accelerate the preparation of good, clean data for machine learning. So with that, I think I'll turn it back to the moderator for questions and answers.
All right, great. Thank you very much, Martha and Pete, for that great overview. So we do have some questions rolling in, and the first one that looks relatively interesting here is, can Paxata save and replay these kinds of data preparation actions? So I hate to use a really old example and show my age here, but almost like, I guess, like an Excel macro. Is something like that possible?
Yeah, so sort of along the lines of what I was just speaking about, that automation feature. So there's two components of that. Paxata can automate the import of data into the library and then the running of the project. So all of those steps that I defined can be run on a scheduled basis. And you might have multiple output points. So one thing that we didn't get to in the demo is that if, for example, I have a series of exceptions that I find, I might publish those to a different location than where I publish my final results for machine learning. But absolutely, automation is part of our platform, and that can be done on a scheduled or event-driven basis.
Okay, great. Now, here's one, is asking if there's going to be future plans for a desktop version, or what is the answer to those individuals or companies that have very, very sensitive data and are hesitant to use a web-based platform?
No, I don't. I mean, we don't have any plans in our roadmap for a desktop version. We do have, we deploy Paxata in a variety of offerings. We offer Paxata as a service, which we run on AWS. We support virtual private cloud deployments as well, and then we do have some on-premise customers. But the processing is done on the server. It's the results that are being returned to the browser, and there is, full security and SSL across that data pipeline. But we don't have any plans for a standalone desktop install.
Okay, great, thank you. Now, what kind of files can we import? We showed some structured data in an example here, but for instance, if we have JSON or XML files, how would that import the data and interpret those schemes?
Sure. So Paxata supports really a variety of structured and semi-structured formats. Both XML and JSON are supported. And we actually do some automatic parsing of those semi-structured files before we bring that data into the library. So the goal is we'll automate the processing or the parsing as much as possible. And then there are some toggle switches if you need to set some additional parameters or where you need your data node to start, things like that. But we have a lot of customers where those are primary file types that they work with. And the great thing about it is that once you get into the Paxata project, the user wouldn't necessarily know the originating data type because it's always going to be presented as rows and columns. So the user experience will be the same working with those semi-structured files in the project as it would if it was a CSV or relational table or anything like that.
Right. Okay, got it. So let's talk about automation for a moment, because manual processes can sometimes be the devil in the details. Is it possible to schedule jobs on regular intervals or even odd, irregular intervals?
Yes. So there are really two, I would say, pieces of automation in Paxata. We do import data into our library. So you could set up data to kind of prime in the library on a scheduled basis. So every time there's a new file or every time yesterday's data is complete, or even more near real time, we do have some customers that are updating data, for example, from S3. We glob those files together, we bring them into the library. So there's automation for that step. And then there's also automation of the running of the project and the results, which we publish as answer sets. And all of the automation capabilities in Paxata, there are point-and-click user interfaces to perform time-based scheduling. And then we also have a very robust REST API where there are endpoints that make it easy to integrate with enterprise schedulers. So if you wanted to have more of a event or trigger driven process, you know, as soon as this other process is done, kick off Paxata, you can absolutely do that as well.
Okay, great. So then in the events where you want to plan ahead against issues like model decay and set up a regular retraining interval, you could actually use Paxata to prepare the data set and then pass it off to your training process, all in an automated API-based manner.
That's correct. That's absolutely right. Yes.
And I would say that that's certainly the recommended approach from a developer's perspective. Okay, so a couple more questions here. One I'll just take here. Yes, this video will be recorded and available afterwards. Everybody that has attended today will get a follow-up email, sort of a thank you. And in that, there will be a link to the video and any questions that may have been asked that we didn't get answered. We'll try to get those answers in there. And give us 2 to 3 days for that to get that video properly edited and in a format that's shareable and socializable. So we've got a couple more rolling in here. We have a couple more minutes, so let's see here. So here's a question about importing a specific file type, PCAP, our binary network log files. So what would be the best practice from Paxata's point of view of standardizing on a method to take a file format that may or may not be supported? I don't want to presume anything here, but to get that imported. And so these PCAP files, I guess, we don't want to get into the weeds on what format that is, but what's Paxata's advice for taking a file format that may not be importable and then converting it to something that is importable and moving on from there?
Yeah, that's something I haven't run across, that particular file type, so I need to do a little bit of digging. But in general, you know, obviously the first option would be converting to a file type that is supported. So if there's another third-party tool that could convert something to, you know, any type of delimited file with really any type of variable delimiter, Paxata will be able to read that. So also extensionless files. So sometimes just removing the extension on the file, if the file is, the underlying data is actually delimited by something, just removing the extension, Paxata can infer that and give the user some options for that automatic parsing. But if you know, if you have the details on whoever's asking the question, Chris, or way to get back to them, I can do some work on looking into that PCAP format that you mentioned.
Yeah, absolutely, absolutely. And another question here that I think I could take is, I've just lost it. Is Paxata a product of AWS or is it a user of AWS? How is Paxata and AWS related? So Paxata is a partner, APN, as the Amazon Partner Network. They are a partner. Forgive me, Paxata, I'm not sure which tier, I forget, but they have the ML competency, so I know that they are sufficiently advanced partner. And if I understand correctly, the Paxata infrastructure does run on AWS, but they are not part of AWS in terms of I've lost my word there, affiliate or a subsidiary. It's their own individual company.
Yes, so that's correct.
You could relate those. If I could make the analogy of a Netflix, for example. Netflix is not affiliated with Amazon or AWS except to be a customer of Amazon Web Services, and they run on the AWS infrastructure, but they have their own business models, their own billing procedures, and their own company.
That's 100% correct, Chris.
Okay,
yeah.
Good. I guess I should have handed that one off to you. So let me see here. There was one here. I want to make sure I understand what they're asking. Can Paxata extract multiple sources from multiple sources of and format like sensor data and contextualize with other static data? So I guess this is a question about, you showed the capability to infer that a misspelling of one word and the correct spelling, you want to replace those with a unified spelling. So can it contextualize over different sources of data? And by sources, I think we mean different files.
Yeah. So so a couple points there. There are two ways that really bring data sets together, and we do that in the context of a project. So if you have you know, sensor data that you want to bump up against some data that you have in a warehouse or local data that you need to join with data in S3 or sort of rationalize together. You would bring those distinct files together in a project. You would leverage Paxata join capabilities to find matches across those data sets, or potentially unioning those data sets together. So those are both ways of bringing disparate sources together. And then all of the transformations, which we really just touched on a handful of them, but there are a lot of transformations and the ability to create calculations and flags in Paxata that would allow you to kind of rationalize those data sets together and create some additional context. So I think the short answer is yes. As long as the data types are supported, it's very easy to bring disparate data together in Paxata. And specifically with sensor and log data, there's some features like the ability to use regular expressions to split data that's in a single column across multiple columns. Some features that we didn't get to in this demo, which check out our website or request a more specialized demo of Paxata. We'd be happy to get into those details. But a lot of additional capabilities we weren't able to get to in the time allotted today that can help with different types of files.
All right, great. So it sounds like there's a lot more advanced features that we weren't able to get to today, and which actually is a perfect seg for the last question of the day. And is how can we, if those that are interested, how can they get more hands-on tutorials, training? Do we suggest that they visit the site, or do you have some special instructions there?
I just noticed that you put up the next step slide. So there are the links on this site will provide links to some documentation, some joint ebooks that we've put out to highlight our capabilities specifically on AWS, and then we do offer trials as well, both trials in our SaaS offering, which we run and do all the DevOps for. We run that on AWS, or we could also support trials in virtual private clouds in customer AWS environments. So click those links and we'll get back and work with you directly.
Fantastic. All right. Thank you, Martha. Thank you, Pete. I want to just make sure, we thank you once again for presenting today. This is a fantastic product. I highly recommend it to anybody that's listening today to give it a try, give it a look, kick the tire, so to speak. And then thank you, the audience, for attending today. Once again, we'll have a follow-up email with a survey in that. Please take the time to fill out the survey. That helps us make these webinars more informative for you and better use of your time. And with that, we are going to sign off for today. So thanks again.